ringing in digital controllers. Ringing in digital controllers. Suppose Dia Visit is a controller, digital controller. It is 1 plus P Z power minus 1 is the digital controller. Let us assume that P has two values. The first case it has plus 0.9, and in the second case the P has a negative value, minus 0.9. Let us consider the first case. Now, what is D of Z? D of Z is M of Z upon E of Z. Because for digital controller, the input is error E of Z. What is the output of the controller? M of Z, controller output. Therefore, M of Z by E of Z equal to 1 by 1 plus 0.9 Z power minus 1. Or it can be written as M of Z plus 0.9 Z power minus 1 M of Z equal to E of Z. Or if you write in time domain, you will get M of K. Sample domain, it becomes M of K 0.9 M of K minus 1 equal to E of K. Let us assume that this error signal is E of K equal to 1 when K equal to 0. When K equal to 1, K equal to 2, K equal to 3, etc., its value is 0 at only one instant. That is when K equal to 0 only it exists. That is E of K equal to 1. For that, what is the controller output? Let us check. That is M of 0 equal to M of 0 equal to, this term will come to the right hand side. That's why that is equal to minus 0.9 M of K minus 1, that is minus 1, plus E of 0. That is M of minus 1 also 0. The controller output, earlier controller output is 0. Initial value of the controller is 0. Therefore, M of 0 equal to minus 0.9 multiplied by 0 plus E of 0 is 1. Therefore, M of 0 equal to 1. That is the controller output at M of K equal to 0. What is the controller output when K equal to 1? That is M of 1 equal to minus 0.9 M of 0 plus E of 1. The error signal is exists only at K equal to 0. Therefore, this is also equal to 0. This is equal to 1. Therefore, this can be written as minus 0.9 multiplied by 1 plus 0. That is equal to minus 0.9. Therefore, M of 1 becomes minus 0.9. What is M of 2? M of 2 equal to minus 0.9 M of 1 plus E of 2. This is also equal to 0 because it exists only at a pulse came at K equal to 0. That's all. Error pulse came. That's all. Therefore, M of 2 equal to minus 0.9. M of 1 equal to minus 0.9 plus 0. Therefore, that is equal to 0.81. M of 2 equal to 0.81 positive value. M of 3 equal to what? M of 3 equal to minus 0.9 M of 2 plus E of 3. This is also equal to 0 because it doesn't exist afterwards. So, minus 0.9 multiplied by 0.81. If you multiply that is equal to minus 0.72. M of 3 equal to minus 0.72. Negative value. So initially it is positive. Then it becomes negative. Again it becomes positive. Again it becomes negative. So if you plot this controller output, M of K if you plot that, initially it is when k equal to 0, it is 1. Then it becomes minus 0.9 when k equal to 1. K equal to 1. Then k equal to 2, what is the value? 0.81, but positive. It becomes 0.81, but positive. Again, it becomes negative. The value is 0.72 negative. So it is alternatively, it becomes positive, negative. This is called the controller output is oscillating between positive value and negative value. This is called ringing effect. Ringing. So the controller itself, now let us consider the case 2. The case 2, P equal to minus 0.9. Therefore, M of k equal to minus plus 0.9, M of k minus 1. Here, it becomes negative because if you bring this to the right hand side, it becomes negative. But here, this is already negative. That's why it becomes positive on the other side. Plus E of k. Here also, let us consider the same case. E of k equal to 1 and k equal to 0. And it is k equal to 0, it is 1. Otherwise, it is 0. So if you substitute and find the M of 0, if you find the M of 0, M of 0 equal to plus 0.9. Old value of control output is 0. Plus E of k equal to 1 when k equal to 0. Therefore, M of 0 equal to 1. What is M of 1? M of 1 equal to plus 0.9 multiplied by M of 0. M of 0 plus E of 1. That is equal to plus 0.9. M of 0 is 1. Plus E of 1 is 0. Error doesn't exist at all other sampling instance. Therefore, that is equal to plus 0.9. M of 2 equal to what? M of 2 equal to 0.9. M of 1 plus E of 1. That is equal to 0.9 multiplied by 0.9 plus 0, because error doesn't exist at all other sampling instance. That is equal to plus 0.81. M of 3 equal to what? M of 3 equal to 0.9 multiplied by M of 2. M of 2 equal to 0.81 plus 0. That is equal to plus 0.72. That's all. So the all values are positive, again positive, again positive, again positive. That's why if you plot this this controller output, initially it is 1, k equal to 0, k equal to 0. When k equal to 1, it becomes 0.9. When k equal to 2, it becomes 0.81. 0.81, here 0.9. It decreases to 0.72. So it is not oscillating. Therefore, if p value is positive, it is oscillating. It means d of z equal to 1 upon 1 plus 0.5 z power minus 1, 1 plus 0.6 z power minus 1 means both will introduce oscillations, whereas 1 upon 1 minus 0.5 z power minus 1 means, and 1 minus 0.6 z power minus 1 means this will not introduce ringing effect, but these two will introduce ringing effect. That's why we have to factorize the digital controller and we have to check for any positive coefficient of z power minus 1. Any positive coefficient of z power minus 1, it will introduce ringing. Now let us consider a controller. What is the drawback here? This controller itself introduces oscillations. That's why the input is oscillating. Input to the system is G of S is oscillating. That's why the system starts oscillating. Therefore, the controller itself introduces the oscillation if the coefficient of z power minus 1 is positive. Let us consider a case. D of z equal to 1 minus 0.3 z power minus 1 upon 1 minus 0.4 z power minus 1, 1 plus 0.5 z power minus 1, 1 minus 0.6 z power minus 1. This is the digital controller, factorized. We have to factorize. We have to check for this. This will introduce ringing. This will introduce ringing. It's not a desirable characteristic of the controller because the controller itself introduces oscillations in the process. That's why this ringing effect should be eliminated. How to eliminate that? For that, we have to replace this by, we have to multiply this term in the numerator and denominator. That is 1 plus 0.5 z power minus 1. In denominator also we have to introduce one more term, 0.5 z power minus 1. But in the denominator, we have to introduce limit z tends to 1. Therefore, what will happen? Numerator, it will be as such. The denominator, it becomes 1.5. 1.5. So replace this here. What you will get? 1 minus 0.3 z power minus 1 multiplied by 1 plus 0.5 z power minus 1 divided by 1 minus 0.4 z power minus 1, 1 plus 0.5 z power minus 1, 1 minus 0.6 z power minus 1 multiplied by 1.5. These two getting cancelled. Therefore, we will get 1 minus 0.3 z power minus 1 whole divided by 1 minus 0.4 z power minus 1, 1 minus 0.6 z power minus 1 multiplied by 1.5. Multiplied by 1.5. That is d of z. That is d of z. Now the ringing effect is eliminated. No ringing effect. No ringing effect because the positive coefficient term is removed from that digital controller and it is replaced by 1.5. That's why there is no ringing in the controller. So this way we can eliminate ringing in the digital controllers.